KURINJI Senior Secondary School, CBSE, Namakkal.
Successful result producing school in state every year.
Administered by the Board of Directors with over 35 years of experience in the teaching field.
Special attention on art, craft, music, dance, silambam, yoga, skating and karate.
Focus on Hindi Sabha and Spell Bee Olympiad exams.
Smart class for effective and innovative learning and well-furnished library.
Solitary importance on sports and games in state and national level.
WhatsApp facilities to know activities of students and school inside the campus.
Free bus for LKG to 8th standard.
Free, hygienic and nutritious food.
NEET, JEE, IIT coaching experts from Rajasthan and Andhra Pradesh along with our effective teachers.
Admission registration for classes LKG to +2.
KURINJI Education Institution, Kavetipatti, Namakkal. Admission in progress. CBSE, KG to 12, contact 9025895176. Metric 6 to 12, contact 9344567484. For online admission, log on to www.kurinjischoolnkl.in.
In continuation to the last class, so we are in a discussion about Newton's third law. What is Newton's third law? Yesterday itself we discussed, but I will repeat once again. For every action, there is an equal and opposite reaction in this nature. For every action, there is an equal and opposite reaction in this nature. Right? So, this is said to be Newton's third law. From that, you can also write, okay, suppose if action is force, reaction is also force, right? So, force is not single in nature. Force always occur in pairs. Okay, right. In continuation to the last class, today we are going to discuss some other information. See this. The terms action and reaction in the third law mean nothing else but force. Just now also I told you the terms action and reaction in the third law mean nothing else but force. Using different terms for the same physical concept, can sometimes be confusing. A simple and a clear way of stating the third law is as follows. Okay. So, he is going to define the Newton's third law of motion in some other manner which avoids confusion due to the usage of same physical concept in different terms. Okay, right. So, what is the statement? Force always occurs in pairs. Full stop. Force on a body A by B is equal and opposite to the force on the body B by A. Yesterday also I drew some picture, right? According to that picture also you can understood what is the information I wrote here. So, what I am saying, force always occurs in pairs. Force on a body A by B is equal and opposite to the force on the body B by A. Force on the body capital B by capital A, right? So, force is equal and opposite. Force is equal in magnitude and opposite in direction. Okay, right. Next, in continuation to the above, the terms action and reaction in the third law, may give a wrong impression, right? The terms action and reaction in the third law may give a wrong impression that action comes before reaction. Okay? That is, action is the cause and reaction is the effect. There is no cause-effect relation implied in the third law. The force on A by B and the force on B by A act at the same instant. By the same reasoning, any one of them may be called action and the other as reaction. Okay. So see this paragraph. This paragraph is telling us, is explaining us how we need to understand the Newton's third law. How we need to understand Newton's third law of motion. Okay, right. So what he is talking about action and reaction. The terms action and reaction in the third law may give a wrong impression that action comes before reaction. So what he is saying, action is the cause and reaction is the effect. And if you go in deep, if you think deeply, there is no cause effect relation implied in the third law. The force on A by B and the force on B by A act at the same instant. So this is the point we need to understand, right? The force on capital A by capital B and the force on capital B by capital A act at the same instant, at the same time, at the same instant of time. By the same reasoning, any one of them may be called action and the other is reaction. Okay. So there is no fixed. For example, the force applied by A on B is action. The force applied by B on A is reaction. Like that we need not to say. Okay. Suppose if the force acting on B by A is action. The force acting on B by A is action means the force acting on A by B is reaction. So here action and reaction are not fixed. Suppose if one is action, the other one is reaction. Suppose if one is reaction, another one is reaction. I will tell you clearly. For example, there is a rough surface and it is A and on the top of that B is there, right? Here suppose the force acting by B on A is action means by A on B is reaction. Okay. So reverse also you can take. So that only he is saying from this paragraph. Okay. Next, action and reaction forces act on different bodies. Action and reaction forces act on different bodies, not on the same body. Not on the same body. Consider a pair of bodies A and B according to the third law. Consider a pair of bodies A and B according to the third law. FAB is equal to minus FBA. FAB is equal to minus FBA. So theoretical statement, I mean just like a statement he is writing. Force on A by B, force on capital A by capital B is equal to minus force on capital B by capital A minus force on capital B by capital A. So these two are same, just we are writing in the form of sentence, right? FAB means it is force on A by B. So notation and representing of notation and what is that reproduction, I mean orally speaking is also important in physics. So this whole sentence we replace just with FAB, but writing is not only the completing thing. So we have to pronounce that, we have to say that in words. So FAB means force on A by B. Similarly, FBA means force on B by A. So that you can write FAB is equal to minus FBA like notations or symbolically. Okay, right. So what I am saying here is action and reaction forces act on different bodies, not on the same body, right? For this statement, I will give you one best example. When a body is in circular motion, right, two forces will act on that body at that moment. When a body is in circular motion, when a body is moving along the circumference of a circle, two forces act on the body, right? The primary force is centripetal force. The initial and primary force is centripetal force. Okay. So centripetal force is the force which acts towards the center of a circle, towards the center of a circle. Okay, right. Based on the frame of reference, based on the frame of reference, you may have one doubt. What is meant by frame of reference? Right. So here frame of reference is nothing but the reference what we are taking to decide the state of an object. For example, when class is going on, all the students are in the state of rest with respect to the wall. So here wall is the frame of reference. Wall is the frame of reference, right? Similarly, whatever it may be, to decide the state of one particular object, whatever you are taking as a reference, whatever you are taking as a reference, it is like frame of reference. But there are two different types of frame of reference to consider. One is inertial frame of reference, another one is non-inertial frame of reference. Next, what is inertial frame of reference and what is non-inertial frame of reference? Right. The frame of reference in which Newton's laws are valid, the frame of reference in which Newton's laws are valid are called inertial frame of reference. The frame of reference in which Newton's laws are valid is called inertial frame of reference. Inertial frame of reference. Next, the frame of reference in which Newton's laws are not valid, the frame of reference in which Newton's laws are not valid is called as non-inertial frame of reference. Non-inertial frame of reference. Okay, right. I will say in another way also for inertial frame of reference and non-inertial frame of reference. I can say that when a body is moving with uniform velocity, I mean uniform motion, when a body is in uniform motion like earth, then if you take that body as a reference, then you can say that it is inertial frame of reference. Suppose if you take a moving bus as a reference and that bus is also moving with some acceleration, for example at t is equal to 0 seconds it is at rest, t is equal to 10 seconds it is moving with 10 kilometers per hour, t is equal to 20 seconds moving with 30 kilometers per hour, t is equal to 30 seconds moving with like that. So it is moving with some acceleration, it is not in uniform motion, it is not in uniform motion. So when a body is moving with some acceleration, if you take that body as a reference, then you can say that it is non-inertial frame of reference. It is non-inertial frame of reference. Okay, that is. So now I explained you what is frame of reference, what is inertial frame of reference and what is non-inertial frame of reference. Non-inertial frame of reference. Okay, right. So come back to the situation where we had a discussion. Action and reaction forces act on different bodies, not on the same body, right? So if you take a body which is in circular motion, which is moving along the circumference of a circle, okay, at any instant of time. So basically just to get the circular motion for a body, first it requires centripetal force. Afterwards depends upon the frame of reference, whether it is inertial frame of reference or non-inertial frame of reference, another force starts to act on the body, that is centrifugal force. Centrifugal force. So one force is centripetal force, that is towards the center. Another force is centrifugal force, that is away from the center. But here, though there are two forces acting on your body, acting on one body, one is centripetal force, another one is centrifugal force. These pair of forces, centripetal force and centrifugal force, not satisfying Newton's third law of motion, because these both the forces, what is centripetal and centrifugal, acting on one body, right? That is the reason. So I am giving example to the statement, that is action and reaction forces act on different bodies, not on the same body, okay, right. Next, thus if we are considering the motion of any one body A or B, only one of the two forces is relevant. Only one of the two forces is relevant. It is an error to add up the two forces and claim that the net force is 0. It is an error to add up the two forces. It is an error to add up the two forces and claim that the net force is 0, okay, that is important. So this is also talking about, this information is also about Newton's third law of motion and the nature of forces and how we need to understand the Newton's third law of motion. Next, however, if you are considering the system of two bodies as a whole, FAB and FBA are internal forces of the system, right? Now, when we are talking about this sentence, we have to imagine there is a rough surface, first A, and on the top of the A, B, and A plus B, this whole as a system. When you are taking this whole as a system, then the forces FBA and FAB are like internal forces of the system, not the body of the system. For the whole system, the forces what we are taking are the internal forces. Next, they add up to give a null force. Internal forces in a body or a system of particles thus cancel away in pairs. This is an important fact that enables the second law to be applicable to a body or a system of particles. Right. Here, this 5 lines of information is talking about internal force and external force and Newton's third law and Newton's second law also. When you are taking two bodies as a system like A and B, regarding the system, the two forces FAB and FBA are like internal forces. But one thing is very important, internal forces will cancel each other. So when internal forces will cancel each other, then what happens? The external force whatever is applying, that is the only thing which is applicable to a body or a system of particles. So in Newton's second law of motion, we concluded, so the force is acting on your body means that is external force, right? That is external force only. So this information or this paragraph is satisfying or giving clarity about the relation between external force and a body or system and the impact of internal forces regarding the external force or Newton's second law of motion. Okay, right. So just now we discussed about Newton's third law of motion and the nature of forces involved in Newton's third law of motion and what is the example of Newton's third law of motion. Clearly, example means not satisfying Newton's third law. This example makes us to understand Newton's third law as much as depth. Next, we went to discuss the impact of internal forces regarding the external force or Newton's second law of motion, right? Now, based on that Newton's third law of motion, we are going to discuss one best example, right? So this example has great importance because here we can understand and we are going to calculate the change in momentum along with the direction. So this problem not only for board point of view, for NEET and JEE mains point of view also important. Problem is simple, but understanding is very important, right? So this model problem can expect definitely one from this chapter, laws of motion, either for board or for NEET or means. Okay. First I will read the problem. First you try to understand the problem. So understanding the problem means what? First, what are the things they have given? Based on that, what he is asking to find? What he is asking to find or what he is asking to calculate. Okay. That's it. That's it. That is the understanding of problem. Right. See here. Two identical billiard balls strike a rigid wall with the same speed but at different angles. At different angles and get reflected without any change in speed as shown in the figure. I will repeat once again. Two identical billiard balls strike a rigid wall. So this is the wall. So you have to see the pictures also. When I am reading the information, you have to see the picture. Otherwise you see the picture first, I will explain you. So it is a wall, it is also a wall. In this case, suppose for example A. In case A, the ball is coming like this. After hitting to the wall, it is also moving along the same direction back. Okay. If you come here, in this case B, right? So the ball A is coming like this, and after hitting to the wall, it is moving like this, in this direction, right? So the angle made by the direction of initial velocity before hitting is 30 degrees, and after hitting also it makes 30 degrees while leaving the contact with the wall, right? Now you see this information. Two identical billiard balls strike a rigid wall with the same speed. With the same speed. So here also U, here also U, but at different angles. Here the angle is how much? Here the angle is 0. Angle is 0 with the horizontal, right? Angle is 90 degrees with the vertical, but we are taking horizontal as a reference to measure the angle of incidence at which a ball is going to incident. Okay, right. So it is 0 degrees, it is 30 degrees at different angles and get reflected without any change in speed as shown in the figure. Without any change in speed as shown in the figure, right? What we need to calculate or find? What is the direction of the force on the wall due to each ball? What is the direction of the force on the wall due to each ball, right? Next, the ratio of the magnitudes of the impulses imparted to the balls by the wall. The ratio of magnitudes of impulses. The ratio of the magnitudes of impulses imparted to the walls by the wall, right? Okay. First we are going to discuss about case A. Next we are going to discuss about case B. Right. See this. Case A. See this. So it is the wall. Momentum initial. So this one. P of x initial, that is equal to mu. Next, Py of initial, right? Px of initial is mu. Py of initial is 0, because when a ball is moving along x-axis, what about its component? What about the component of momentum along y-axis? It is 0. It may be like this, mu cos 90. Mu cos 90. So cos 90 is 0, no? Then automatically mu cos 90 is 0, so that we are writing 0. Please try to understand. Next, P of x final. So this is, see the arrow mark, it is the final. So P of x final is minus mu, because the magnitude is mu, but it is moving like this, no? It is moving like this, right? So when it is moving like this, it is minus mu, okay, right? P of y final, Py final is equal to 0, right? So final also, regarding this one also, it will become like mu cos 90, that is equal to 0, okay, right? Now, impulse is the change in momentum, impulse is the change in, right, what is impulse? Yesterday we discussed. So impulse is the change in momentum. It is also a vector quantity, okay, right? What about the direction? So Before going to talk about the direction, I will go through the magnitude. See here, x component of impulse. So impulse is nothing but change in momentum. Change in momentum. X component of impulse is minus 2 mu. How? See this. So momentum, change in momentum means what ma? Mv minus mu. Otherwise, final momentum minus initial momentum. Okay, right. First you take the x component. Regarding the x component, okay, so change in momentum is nothing but minus mu, right? Pf minus pi, Pf minus pi, okay na? So Pf means what? Minus mu, right? Minus pi means mu, no? So minus mu, minus 2 mu, minus 2 mu, okay, that is. Next, y component of impulse, y component of impulse, that is what? 0. Y component of impulse is 0, okay, because it is 0, this is also 0. So finally 0 minus 0 is equal to 0, right? Okay. Now next we are going for case, right, 1 minute. So after completion of discussing about magnitude, I am coming to discuss to the direction. So what is the direction? Because momentum is a vector quantity, no? So change in momentum is also vector quantity. What about the force? Because force is the change in momentum by time. Time is a scalar quantity, right? Okay. So direction is normal to the wall along positive x-axis. So just by seeing this, because it is 0, no? So by seeing this you can answer it is normal to the wall along negative x-axis, normal to the wall along negative x-axis, okay, right. Next we are going to discuss next case, case B. In case B, the ball is coming to incident at 30 degrees angle to the horizontal. The ball is coming to incident at 30 degrees angle to the horizontal, okay. That is P of x initial is equal to mu cos 30, because it is mu, no? It is mu, P of x initial, right? So this is like and this is like. So here also it is 1, it is 1 if you split into two components. Resolution of a vector. So P of x initial is equal to mu cos 30. Similarly, P of x final is minus mu cos 30. This is right, minus mu cos 30. Next, P of y, what is that initial? P of y initial. See here. So it is this one. It is what? Minus mu sin 30. See the light. Minus mu sin 30. Next, P of y final. This one. Right. It is what? Minus mu sin 30. Minus mu sin 30. Afterwards, as usual, x component of impulse. This one minus this one, minus 2 mu cos 30. Y component of impulse. This one minus this one. So this one minus of minus this one, minus into minus plus will come. Both will get cancelled. So it will be 0. Right? If you find the resultant, afterwards, what is the direction? Because he is asking direction also, right? So the direction of impulse is the same as in A and is normal to the wall along the negative x direction. So this is, here also this is, and here also this is. It is normal to the wall along the negative x direction. Okay, right. As before using Newton's third law, the force on the wall due to the ball is normal to the wall along positive x direction. But before using Newton's third law, because one is action means the other one is reaction, right? The force on the wall due to the ball is, okay. So if one is along negative x-axis means the other one is along positive x-axis, right? Finally, he is asking the ratio of magnitude of the impulses imparted to the balls in A and B is, right? In A it is 2 mu. In A it is 2 mu. In B it is 2 mu cos 30. In B it is 2 mu cos 30. Okay. So here it is mu will get cancelled ma. So 2 cos 30 is root 3 by 2. 2 will get cancelled. Finally 2 by root 3. It is approximately equal to 1.2. Okay. So in this class, in today's class, we discussed how to understand Newton's third law of motion completely. Next, the best example of Newton's third law of motion to understand. Okay. Next, what is the impact of internal forces regarding the external force and Newton's second law of motion. Next, we discussed one example problem based on this change in momentum and calculating of force, and finally we found the magnitude of impulses imparted to the balls in A and B, that is, okay, right.